is junction yin, and I will explain the medium transmission line exercise for lab 3. So let us see the lab sheet here. For this exercise, it requires us to find the ABCD constant sending end voltage, current, power factor, and power when the line is delivering full load of 50 megawatts and 132 kilowatt, 0.8 power factor lagging, transmission efficiency, receiving, and voltage and regulation. So now let us look at the coding for this exercise. So basically, this coding is already provided in the lab sheet, so we just need to paste it in our MATLAB program. So you can see here the purple wording here is to like purple color wording here later will display. This let us to declare the function later in common windows. So this is the variable to the calculating the variable all here. So the purple color wording here is all will display in common windows later. The value of display, the value of ABCD here. So the IR here is stand for load current. And then the next row is for voltage, and the BS is for the sending end voltage. So if we click the run button here, the command window will directly appear this wording, enter the length of line, receiving voltage, power factor, and RLC. So we have to key in the value for those needed value, RLC value, and so on. We just need to type it here: 200, 132, 50, 0.8 for power factor, and then inductor value, resistor, and capacitors values. After we key in, we click the enter key, then it will directly appear this medium transmission line by nominality method. So the first row here that I highlighted here is for the answer for the A, which is here. Display A. This is for the answer. So the next row is for the B and C, D. So this one is the load current 0.2. We get in MATLAB is MATLAB simulation answer is 0.2734. And then VR here is 76.2102. The VS, the sending end voltage is 83.0314, which is same as the manual calculation that we do. Let us compare here. So it's all similar except for the value of the efficiency transmission value, and the regulation value is different. So for that part, my other group member will explain about it. So that's all for my part. Thank you.
Assalamualaikum and hi. My name is Nur Aini Nadira binti Kamara Arifin, and my metric card is CE190049. So in this video, I will continue to show the simulation, the output, and the manual calculation for this lab 3, which is medium transmission lines. So I will continue from VR. This is the common for VR, and the output is here 76.2102, and then this is for VS. VS is 83.0800 plus 22.68931, and then print F sending and voltage VS is percentage F slash N for the, and this is common output for the common. And then VSL, The output is here. And for IS is equal to VR times C plus D times IR. The output is 0.2670 plus 0.0452. And then registry 3 times conjugate versus conjugate A negative minus VR times 100 divided by VR. And the answer is 73.713379. And for the pulse, the common like this, and the answer is like this. Then the efficiency FP times 100 divided by pulse, it equal to 80.2367 minus 37.2240I. And for the VRNL, the common output here. For the VR no load, for the PCR, the common is VRN1 minus VR times 100 divided by VR. So the output is 11.858405 plus 29.4344I. So the percent regulation is 11.840472. And for the manual calculation is slightly different from the simulation. And for the common is that we copy from the lab sheet. Here, we just need to copy and paste to the MATLAB. And we just need to do the manual calculation in order to differentiate to make sure that the simulation is the same as manual calculation. So that's all from me. Thank you.
Hello, Assalamualaikum. My name is Syamil Bakri Ibrahim. My metric card is CA190170. So today I would like to explain about this lab 3. For my part is I'm going to do for this exercise 1, Y bus metric. So we have 3 Y bus, which is Y bus 1, Y bus 2, and Y bus 3. So I'm going to explain from step by step, 1 until 3. So as you can see, this is the command that I take from our lab sheet. So we need to do this command. We just paste this command and then we need to run for this to get the output from this command. So as you can see, the input here is inter number of buses, inter number of impedance, inter starting bus number, receiving bus number, impedance of bus, and line charging admittance. So we have 3 bus. So for this first one, Y bus metric is number bus. So number of bus is 3, number of impedance is 1. So starting bus here is 1, as you can see from our lab sheet, 1 until 2, and receiving bus is 2. Impedance is 0.1 plus 0.3J, and line charging admittance 0.02J. So this is the output from the matrix, as you can see here. So this is for Y bus 1. So I'm going to continue for Y bus 2 and Y bus 3. Okay. Hi, Assalamualaikum. So I'm going to continue for the Y bus 2. So as you can see, the command is still the same. So we need to change from the output. We need to put the value here is the starting bus is 2 and receiving bus is 3. So as you can see here from our lab sheet, is starting bus is 2 and ending bus is 3. So previous Y bus 1 is starting bus is 1 and ending bus is 2. So it's slightly different from the Y bus 1. So the impedance of bus is 0.15 plus 0.5J, and the line charging admittance is 0.0125J. So it's just the same from this lab sheet, I'm just going to put the same value as here. So this is the output from the bus emitter matrix is here, as you can see. So yeah, I'm going to continue for the Y bus 3 for the next video. Okay, thank you. Hi, okay, so I'm going to continue for this Y bus 3. So it's still the same for this command, nothing changed. So it changed to the output when I run this simulation. So as you can see, number of buses is still 3, number of impedance is still 1. So the starting bus is different from this previous Y bus. So it's starting is 3 and receiving bus is 1. So as you can see here from this lab sheet. And impedance of bus is 0.2 plus 0.6J, and the line charging admittance is 0.028J. So as you can see here from this lab sheet, we just put the value that it stated from our lab sheet. So the output is here, as you can see, bus emitter matrix is here, the output. So that's all from this lab 3 for my part. So we have Y bus 1, Y bus 2, and Y bus 3 with a different value. So yeah, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan Shakir bin Muhammad Amzani. My matrix number is CE1900805. I will present to you about the short transmission. So I will explain about the command window. For the first one, we have a command for VRLL equal to 220. And then the second one, we have a command VR. And then next one, we have a command Z. The fourth one, we have a command display. Next, we have a command SR. And then we have command IR. We have a command IS equal to IR. We have a command VS equal to VR plus Z IR. We have a command VS LL. And then for the last one, for my part, we have a command SS. So I will pass to my group mate, Iquan, to continue the presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairi Iqbal Bihamdan. My number matrix CE190216. I will continue for this part. This is for nilai to REGE. This value for EFF, right? This value for display. This value for SR. Okay, this value for IR. All right, this value for IS equal to IR. This value for VS equal to, value for VS, sorry. Okay, this value for VSLL. This value for XS. And this value again for REG and value for EFF. That's all from us. Thank you.
So this is our output for short transmission. Yep. And then it has a slightly different from the manual calculation, but still we managed to get the close exactly result to the manual calculation. So I think that's all from us. Thank you. Assalamualaikum.